Okay, we're just going to do a brief introduction to the excellence part of linear programming, and it basically has to do with the objective function, and if you change the objective function, how that changes sort of your maximum point and so on. So when we did this initial problem with Maroic's watercolors and pastel problem, and we found our feasible region, and we got a point of intersection at here and 16 and 10, or 16 and 0, and here, 6 and 10. Now, I want to show you what happens when you move an objective function through that feasible region, what it all means. So this is our objective function, 40x plus 100y is equal to p. And on software, we can actually plot this little sliding point. So let's say I want the profit to be 200. At a profit of 200, basically, you've got points 5 and 0, 0 and 2 that will give you, a profit of 200, and anything in between those points will give you a profit of 200 as well. And so if I move this p, basically, which is I'm changing the profit that this objective function can get, I'm moving it through. You can see that at approximately this point here, 16 and 0, the profit is $640, and it's also $640 around here. And I keep moving that through, and I can see that it's now left that. It's now moving through the feasible region. And the fact of the matter is, the feasible region, the maximum or optimum point for profit, is when this objective function is the last point that it hits as it moves out of the feasible region. And what point is that? The last point that it goes through to give me, I think, a profit about 240 or whatever it was, is this point, 6 and 10. If I put 6 in here and 10 in here, I will get my profit of 240. So that's how the objective function behaves as you move it through visually as a graph, as how it behaves through a feasible region. Now, what happens if we changed the profit function or the objective function? Say we made it 100x plus 100y. And that changes the gradient of the objective function. And what it does is basically, if you watch, it still moves through the feasible region, but now this line is parallel to that purple line, right? Which is this function here, x plus y is greater than or equal to 16. They both have the same gradient. And so the last place it exits is actually all along this point. This, like from this point here, 6 and 10, to this point here, 16 and 0. That's it. It's all along that line that we get a profit of 590. So all along here, from 6 to 16, basically along the x-axis, all of these points along this line between these 2 points here will give us a profit of 1590. So when you talk about solutions, what will give you the maximum profit? Well, there's no one solution that actually gives you a maximum profit. In fact, you get this sort of multiple solutions between 16 and 10 that will give you the maximum profit, because anything along that line will give you a maximum profit, and it'll give you a maximum profit of 1600. So any point, and what you have to go for, because we're talking about watercolors and pastels, is you got to go for like whole number values, right? You can't, I don't even know if we can get whole number values here, but you can't use like 9.1. You got to try to find some whole number values that will work. Well, 10 and 6 works, and that makes sense. And then you got to try to find some more whole number values, because you don't want to, you can't have a 13 and 3. So you can't have 0.1 of a painting. So between these values here, you've got to find some whole number values that work. And that's really the essence of excellence.